All right. Welcome back, everyone. Okay, now for the last session of the two-day workshop that we have, we're going to have a unconference or Q&A session. We've invited all the speakers from today and yesterday back on stage. So if anyone out there in the audience have questions, please raise your hand, and we'll try to answer your questions. And we also have some questions for the speakers we'll ask as well. I don't know if we need any more introductions. Should we? I'll just mention again, we have Jorge sitting on the far left. We have David, we have Rick, Martin, and Kevin, and I'm Edward. So let's get started. I'll start with the first question, easy question. What do you guys think the effect of AI will have on software development, and specifically in the next, both short-term wise, 1 to 3 years, how it'll affect the software development and programming community, and then maybe long-term, like 5 years on. So who wants to start?
So one thing that has struck me about the AI developments of recent times is that it's extremely hard to predict anything because the developments are going so quick. Models are getting better at an accelerating pace, and accelerating pace is very hard to wrap your head around. In the short term, you can literally pretty much just look behind us, like what has it already done? Well, Stack Overflow is definitely something that has been impacted. People have now inline assistants to write documentation, to ask about APIs, to do Git commit messages. These are all workflow enhancements, right? These are all ways that developers can accelerate themselves, right? So here we are talking about improving your own development speed. And I think for that, it's already extremely useful. But if you try to look ahead into the future, like how good are these models going to be at replacing developers, at not just making them faster, but essentially taking a chunk of their workload? It's kind of all bets are off, but the signals are that it's going to have an accelerating impact on it. And as I said, every time I try to predict AI, I'm wrong. And in this case, my prediction would be that we're on for a wild ride.
All right, great. Anyone else wants to chime in? Yes.
Yeah, I tend to think that, or one thing that I think it could be a comparison. Maybe I'm wrong, I don't know. It's hard to know. But I tend to imagine what was the change. I mean, it was not immediate, it was more gradual. But for accounting people or people who were working with numbers, doing math, when the computers appears, it's like, I assume that there was a huge change for the people doing manual work and having that super duper tool that can do a lot of automatic calculations and math. So I think it's going to be something like this, maybe more with a lot of speed. I mean, it's going to be like a big change. But in the fact, I think it's like having super tool. I mean, you have a super tool that can assist you a lot on the coding activity. But it's not going to replace you. It's going to be more like adapting to a tool that makes you super productive, as Rick said, and yeah, and learning how to make your craft, because programming is like a craft, with super duper tools. I think that it's going to be like this in the next years. I think the Copilot, for example, is a good example of that. I think that you still like, yeah, you can feel or sense that the new manners. I mean, we are all this year figuring out how we should adapt our flow, our mechanisms of working. And yeah, that's probably my forecast.
Much easier. Great. Yeah, so large language models as plausibility engines are very fascinating. And I think there are some challenges along the lines of correctness, which perhaps they'll be solved in the future or not. But right now, they're great at, I think, fostering lateral thinking. So maybe we see developers using these tools to help expand the way that they're solving problems. And perhaps, maybe you've heard of rubber duck development. I think, well, maybe now the rubber duck talks back.
Okay. David, do you want to share anything, or?
I have to.
No, you don't
I have to admit, watching Jonathan's talk, I was very impressed, like how he did live coding in that speed with all the suggestions just filling themselves in. And I think this is the most imminent changes. Most of the others already agreed, like improving our workflows and helping us basically get faster or get the most daunting tasks done by the AI.
Okay, so I think probably one of the consensus is that it's going to be a helpful tool in the short term, at least, to help the current developers. And it's not going to jeopardize any developer jobs, at least not on the higher end. Maybe HTML programmers, if there are still any, maybe impacted. But longer term, it'll be almost impossible to predict, like Rick says. You want to add something, sure?
Yeah, maybe one change that we could notice pretty soon, or already happening, is maybe we are going to shift a little bit. I mean, the typing of the coding could be more automatic right now, or happening like by the machine. And probably we are now with the need to shift or doing more code review, or ourselves. I mean, or code reviewing, code proofing the things that are generated by the tool. I often find myself right now, like, for example, with Copilot, it's like you have to pay attention. I mean, because it's more a mix in between. I mean, there is something that is producing code along with you, so you are kind of reviewing it. It could be also thought like, or compared with the code when you do pair programming. It's like, well, if you practice pair programming, you can switch roles. Like you have the typer and the coder and the other guy that is kind of reviewing what you are doing. In this case, you pass more time in the other side, like in the guiding the process.
Right. Okay.
Yeah, so right now, my experience with it is that you're forced to review code in a way that you're not forced to with humans, because you can essentially have zero trust that it produces a working example, right? And but that is the current state. You know, just as we've seen with image generation models, the improvements that have happened over the last year in there are just astounding. So if you map that same kind of improvement concept to large language model code assistance, then yeah, as I said, that's where my wild ride prediction comes from. Because in the other AI fields, you can see the curve, and so if you extrapolate that onto language models, then yeah, it's going to be interesting.
Great. Okay, Kevin.
Okay, great. Yeah, some very illuminating answers there. I think maybe my next question is actually sort of tangentially related to that. It's about accessibility. So we were discussing this at lunch, and I know it has come up on the Rust forums and on the Rust subreddit and in previous conferences. It's basically a problem that is continuously discussed about, especially when we're talking about new UI frameworks and app development frameworks. So I'll pose the question, how do we think this should actually be solved? Like, what's the ideal solution in your mind, especially when we lack maybe time and funding to spend on its development? And as a follow-up to that, could we perhaps extract the accessibility functions into a library that could be applied to multiple frameworks in some sort of generic fashion? And how do you think that would work, if you think it would work?
Yeah, this is a great question. I'm a firm believer in this concept of nothing about us without us. So I think that improvements to the accessibility stack, and there are probably many, should be made in conjunction with people who use those tools. Otherwise, the solutions that we make will be ultimately rejected. So I think that there's a great potential to improve performance and makeability of accessible technology. But the key there is to work with users of assistive technology.
So we should focus on hiring folks who actually need those accessibility functions and use them in their daily life for, dog fooding purposes, something like that.
Yeah, hiring people and also basically sitting down with users and like seeing how they use the tools. And maybe the solutions that are out there are completely inefficient, but that's probably just because no one's put those two halves together, how it's used and how it's implemented now.
Yeah, absolutely. Great point. Anyone else?
Yeah, so I totally agree there, because the only way I can, imagine accessibility is by trying to close my eyes, for instance, if I'm a blind user, and see, hey, can I navigate the functionality of my application? Because I'm trying to solve the problem of the accessibility structure in our framework. So one of the ways I thought might be an approach is to, at least for the blind user situation, imagine that the blind user is essentially controlling the program through a script, or have a textual or a tree navigational input, just like blind people query the UI structure for like next item, go in there, select, right? And I thought that had a very strong similarity to testing infrastructure that is used to test applications, because they're also blind, essentially, right? They're a blind program trying to traverse a UI structure and execute functions and see the result in a sense of read it out. So I thought that might be a useful way to sort of align the value of testing with the need of accessibility. But so far it's only been an idea, so we'll have to see if that actually is useful.
Yeah, definitely a great point. The overlap between accessibility functions and testing harnesses, they sort of come from the same view. Any other thoughts?
I have two comments on that. The first one is, I think moving to declarative frameworks helps a lot, because that means it's much easier to introspect and get information out and actually write the tools necessary for accessibility. The other thing is, there's a project called ATSPI, which is in the a Linux Foundation project, but also associated with the GNOME Foundation, and they've done accessibility tools and the frameworks for years, and to ensure that the GNOME project supports all that. And I can only recommend anybody who's dealing in that area to take a look. It's not the greatest documentation, but it's a huge project and there's only a few people working on it. But they do have examples, and accessibility is a huge area. Like, this starts with helping people who have difficulty clicking, like double clicking, and just allowing things like a long click or different examples like that. It's not just it's not only blind people who cannot use the screen but have a screen reader or things like that, but it's like a lot in between, and they have good examples. They have lists of how these things can work, and I think they have a really great job. Yeah, so I can only recommend everybody to take a look there, read their documentation.
Real quick as a follow-up, so do you think that could serve as a possible model or basis for an accessibility library that could be reusable in generic contexts across multiple frameworks?
It's very much tied in a lot of the implementation to Linux, so it's hard to say. And I think my biggest criticism is that all these models should concentrate more on the interface that they expect from a UI toolkit rather than on everything below, because this would then very much allow these UI toolkits to better tailor their system for these APIs, rather than always having to understand the entire stack. So I can't really recommend it in that sense, but yeah.
Yeah, so one of the problems as a framework builder I'm facing with the existing APIs, right? For instance, on Apple, you have to generate essentially a ghost UI tree that they can navigate, that the screen readers can navigate, right? So if you're making a framework that is virtual viewporting data or that is, optimizing rendering in some way, that makes that very hard because the items that are not on screen are not in the list, right? They might be even streaming in from a server. So how are you going to give that to essentially a declarative static structure for accessibility, whereas the accessibility API itself to the user is event-based. There is a declarative model in between that is blocking the path from the event model to my event-based model for the UI. So that makes it hard, especially if you are dealing with a framework like ours that is designed to do things efficiently and therefore uses a virtual viewporting on data. So yeah, that's definitely a concern. It's not a concern I can fix in any way because with the Apple platform or the web platform, I'm already tied to generating a shadow DOM structure with ARIA tags or a shadow NS view tree with text content. So there's no way I can fix this. It's just an abstraction that is in the way of the actual user. So if I would see future accessibility APIs sort of going a little bit more low level and dropping the intermediate data structures needed, that would tremendously help implementation complexity.
Great point. Yeah, that's something to think about for future platform developers like David and I. Anything else? If not, we'll move on. Okay.
Any questions so far from the audience? No? Okay, so I'll continue. So all of you have lots of experience developing cross-platform frameworks and systems, etc. So in your opinion, what is the biggest hurdle or bottleneck that currently may exist in doing this cross-platform work? Something like missing, if there's like a magic code crate or whatever that can solve that problem, what would it be, or what area would that be in?
So cross-platform, when you push it to the limit, becomes infinitely hard, right? Because you're on Apple platforms and they have so many intricate little UI features, like, oh, they have a panel feature in the home screen. Oh, they have, other little blobs. They have a screen inset. They have rounded corners in the corners. There's so many bits and pieces of the platform that are actually different from other platforms that being truly multi-platform is hard, right? You're always going to drop features at the edges because they are platform specific, and some people will need that platform specificity. So one of the ways is to accept that and just get out of the way of the developer. And this is what I like about Rust and the fact that we're standing straight on the lower level APIs. If you care, you could just add a function, or you can just call directly into in this case, the Apple APIs or the Android. You can just add some Java code. So I think the best way to approach this as a cross-platform framework developer is to just see if we can get out of the way of the developer that needs access to these specific features instead of trying the infinite task of trying to cover all of these, because there's giant companies outputting APIs per minute that just you won't be able to keep up with.
So for me, I think that the biggest hurdle in cross-platform is the quirkiness of the different platforms that is not documented. And very often you just read documentation. It's so many platforms, so it's hard to test your thesis on each of these platforms. So you read something, you see it should work, the idea you have, you write the cross-platform layer, you implement it for the first few platforms, and then on the 6th platform you realize, oh no, it doesn't behave the way they documented. It breaks your assumptions. You can throw everything overboard again and start with a new model. And this happens much more often than you would expect. And yeah, it's sometimes a really daunting task having to figure out all the small edge cases, writing tests actually for all the platforms just to verify their assumptions are correct because they don't do it. And for me, that's the biggest hurdle.
Okay, I think Martin has some experience with writing some tests.
Yeah, I suppose if I had a magic wand that I could point at any one thing regarding platform differences, it would probably be GPU and GPU drivers. Sitting on a stack that requires rasterization of content on the GPU, the subtle differences between GPUs and the ways that they just completely break when you do something different, I think so much time goes into handling those kind of problems. So if there was some sort of standardization in that realm, I think that would go a long way toward making at least the web as a cross-platform platform working better.
Okay.
Yeah, it always surprised me that we actually only have a few GPU vendors, but we have as many middle layers for as many GPU vendors, which is actually not a solution. It would be, I would say it would probably be nicer if every GPU architecture vendor has a specific API. So NVIDIA has the same API on Linux and Windows, and AMD has a different, but just be vendor specific, because there are only a couple. So now we have the problem of NVIDIA on Vulkan on Linux, NVIDIA on Windows on Vulkan, NVIDIA on DirectX and Windows. So it is like, it's like the abstractions aren't helping. If we would just say, no, Intel has one, Apple has one, NVIDIA has one, and AMD has one, we have four, but then we do have a lot of control, because the differences come from all the quirkiness with the different types of GPUs. Anyway, it's just an idea. Maybe it's a bad idea, but it's always struck me as kind of weird.
Okay. Yeah, that's going to be a hard one to solve. So hopefully Osiris can help in that respect.
I have written graphic drivers in the past, and this is really, like, I had that in my mind when you asked the question, but I thought, let's not mention that. But very often for the graphic driver writers, they don't even know, right? Because it's just only one specific device where that happens. And then somebody mentions it, and nobody cares for these devices, or you don't have enough people to fix it again. So I'm not sure whether the vendor-specific APIs would really help here, because even there you would have the quirks for each different device. And it's just, yeah, it's amazing how much can go wrong just with graphics drivers. And if you look into modern game development or into the engines, they have just a list of quirks for every single graphics card out there and every single edition. So they work around the performance drops and everything everywhere. And yeah, I would like that magic wand as well.
Okay, so maybe just one advice for any junior or developers that are out there, to always write good documentation and note down the quirkiness in any design decisions that you may have. Okay.
All right, we'll move on to a slightly different topic. I want to raise the topic of new device form factors, not just ones that are available now, but in the future. So I think over the last couple of days, we've talked quite a lot about supporting different UIs, having support for different platforms on a bunch of these different combinations. But it primarily focuses on handling the differences in the OS services and the platform-provided abstractions. But as folks who are designing and implementing these abstractions on the web, on native platforms for UI toolkits, do you consider future device form factors? Right now we have smartwatches, we have AR, VR, extended reality coming, but in the future we could have, biometric implants, other things. Do any of these influence your philosophy in UI or platform design? And what can you foresee coming down the road that might influence you in the future?
So I try to do that because I do think that 2D UI is, for instance, here to stay. You can place it in a 3D space, but the way we interact with a UI in a 2D way seems to be rather constant in my experiments with AR and VR as well. It's like, yeah, there's spatial awareness, there's all sorts of things you can do with hand tracking and all that, but nobody has really made the UI fundamentally different in that 3D environment than actually putting an iPad or whatever, a touch area in 3D, but maybe controlling a virtual space or putting screens around you. So I think the main form factor difference is that we're going to lose the screens and they're going to move to your glasses or lenses or something. But other than that, I would say the primary human-machine interface shock is going to come from some kind of AI augmented or neural link connected interfaces. And as I said, these are so wildly speculative that I cannot even comment on what they will be. But imagine something like having an associative memory extension, right? So instead of typing a search in a search box, you only have to think about it, right? So that does away with an entire class of UI problems that no longer exist in that future. So yeah, in the immediate future, definitely I see the UI live on in the next form factor. But beyond that, you know, it's going to be strange.
Yeah, there's also a whole world of completely different inputs. I didn't even consider that in my original question, but that seems to be more of a wild possibility than the output in view form factors. So yeah, that's a great point.
Yeah, that's a interesting question. I mean, I think we've seen presentations the past few days about VR experiences where you control the cursor through eye tracking. Why don't we have that on our phone? Why do we have to constantly like fumble with our giant phones and not be able to click on things? Why can't we just do it with our eyes or some other input method?
Well, on that topic, I remember, you know, years ago I had I think it was a Samsung Galaxy phone, and it could do some rudimentary eye tracking, and you could maybe scroll or like answer an incoming phone call with just a glance. But, you know, that never made it anywhere beyond that phone, and it was, I guess, promptly ditched after nobody really decided to use it. So I guess that also speaks to the importance of maybe thinking about this in UI and platform abstraction design to the point where we could integrate it and preserve it and you know, increase the longevity of those features being available. I don't know. Any other thoughts?
Well, yeah, the difficulty with that is when are you on time, when are you too late, and when are you too early with these technologies, right? Because we've all seen 3D television come and go, right? Which was kind of strange that it went again, but yeah, there was just not enough consumer demand for it, or the technology was too early. And similarly, we're seeing the first commercial device, now the Vision Pro, with eye tracking coming to market. So that means that it might or might not work, right? We don't know yet. We don't truly know yet what will work. This is kind of a semi-experimental, of course, a very, very refined experimental device, but it's still priced and also pushed as an experimental device. So in terms of what we're really going to end up with as the working form factor, I think we're in a wild exploration phase. And similarly, we had VR, right? Everybody's like, "Oh, VR is happening," and you know, it's been happening for a while now, and it's still happening. But that doesn't mean that you could build a business on VR UIs today, because there's just not enough momentum, not enough market to turn that into a business. So the economic consequences of a new technology appearing, searching for a form factor, and then enabling the economic parameters within which you could service these technologies are very important, I think, to what to focus your energy on. As a framework builder, yeah, I love to play with AR, VR interfaces, but I don't think it will be a technology right now that you could scale a company on.
I have more than an answer. It's more a question or a doubt about these kind of trends, because I think, for example, with the VR or these kind of things, I don't know. I'm not sure how it's going to fit. Or, for example, we are all discussing about targeting right now the mobile, desktop applications, web. That's our the typical targets of the stuff that you guys are working, we are working on. But for example, we don't share one space of other targets, like, for example, the game machines, where they target to different platforms, and they target to different type of inputs. Let's think on the joystick for playing video games. I don't know where it's going to fit this kind of new technology, because it's kind of in the middle, or I don't know. I think there are good reasons that probably game machine vendors have to target first to this kind of environments and new technology. But I don't know, maybe eventually all the things are going to target to all the platforms all the time. But what do you think about?
So one of the ways I think a technology like this can accelerate is if there are social forcing factors, right? So imagine that the first small portable AR devices, not the Vision Pro, but like much smaller, are appearing on the market. And people start to have virtual friends, not virtual, real friends that are in a different location, but sitting at the table with them. And the moment that happens, the people that don't have these glasses are going to be you're going to feel socially left out of the situation. And once that happens, everybody's going to buy one. Because there's just like what we have with phones and social networks right now, if you don't join in, you're going to be isolated. And so the moment that happens with these technologies, we've reached a point that they will be instantly everywhere. But until that happens, yeah, I think it's experimental.
Okay, shall we move on? By the way, any questions from the audience at this moment? I think we're about halfway through, but we may call it earlier than that. No? Okay.
So coming from, I actually done some web development, mobile development previously. I think one of the recent frameworks such as React and React Native are very popular. It's because of its declarative nature, very simple for the user to see the code, which sort of matches the UI that they're doing. In terms of in the Rust ecosystem, I know Rick's MakePad presentation was great in terms of that. But what do you guys think is the hurdle that prevents mass amounts of web developers to move to the Rust-based web development ecosystem? What are the biggest bottlenecks, you think, and how do you think it can be overcome?
So that's a very difficult question, because Rust has a fundamental ergonomics problem in that it doesn't have a garbage collector. And a garbage collector is something that UI really can use if you use closures like on-click or little bits of code that run in response to user input, which generally you attach to the UI tree. And with closures, you can access the surrounding data of that closure. But without a garbage collector, implementing closures is not ergonomic, because you need to wrap the data into an RC ref cell in Rust, and that's quite cumbersome. So I would say a web developer coming from JavaScript expecting Rust to be like JavaScript is going to have a bit of a shock, because it's really not. One of the things that I've tried to solve is how do we make it at least not as unergonomic as dealing with RC ref cells everywhere. So that's why we built a poll architecture in the event flow, so that people don't really have to think about how to access their data. It's still kind of like JavaScript. So yeah, I would say that is one of the biggest issues. The other one is ergonomic async, right? Because async is essentially the same problem as a closure. So it needs access to the surrounding state. And in Rust, it's kind of implemented like a hidden closure. So that means that if you want to access your state in an async function, you still need to use RC-RefCell. And I am not going to be able to fix that. I might be able to fix that with IDE shenanigans or something we can do on the developer tooling side, but that is fundamentally going to stay. The only solution I have for that is just make the smoothest, slickest developer tooling for Rust, which is what MakePad is trying to do, so that by enabling people to very quickly drag and drop a UI, maybe the activation energy of learning and working with Rust is overcome enough that they'll take the trouble to do it. But it's definitely the biggest challenge.
Oh, okay, go ahead. I'll ask a follow-up after.
I I have to admit one of the big differences with Rust is that it's harder to produce compiling code, right? You spend more time actually fixing your code, ensuring that, well, it compiles fine, and then there are a lot of errors you can catch early. And we tend to have, or we have this tendency to often say, yeah, this is great about Rust, this is what we love about Rust, and others are just meant to see that. And this is, I think, really hard for JavaScript developers or other interpreted languages, where often it's a runtime thing to catch these errors. And I found it particularly interesting that Josh, in his talk, had a different opinion on that, where he said, no, maybe it's on the Rust developers to try to fix that and say, let's try to produce code even though we know there are errors that we want to complain about. Even though we are saying, yeah, this value does not live long enough, we can still try to produce something and give it to people, hand it to them, and make it easier for them to still execute the code, maybe test it, see when things go wrong, and so on. And I found that highly interesting. I've never really thought about Rust doing that, and I think it's definitely worth exploring.
Please, go ahead.
Yes, I have like a positive thinking about, I think the part of the adoption could be driven by the maturity of the framework itself. If I remember myself learning another languages apart from Rust, I think all the time was, or the better example I have were driven by the first or at the same time learning a framework and not only the language. That happened with me, for example, with Ruby on Rails, pretty known web framework. And also happened with me with another technology where I put focus on learning or practicing the language for the first time, but learning a framework. Because frameworks put you some constraints. You are not going to use the full language. You are going to use just the language, focus in some constraints that are the logics, the rules of the frameworks. So the frameworks, as long they are better, they are competitive with existing solutions. Let's say if the Rust, you have one Rust framework that is the same or competes with Flutter, let's say, I think that makes the adoption of Rust much easier, and I think that with the time it's going to be secondary. That's a positive feeling that I have.
So it sounds like we're converging on the topic of what can we do to make Rust easier to use. So on that note, I have a couple of follow-up comments to what you guys have said. In regards to the garbage collector comment, there actually are some crates that offer garbage collector implementations in Rust. You can grab them and use them. Of course, that comes with the problem of, oh, this isn't standardized by like the core or the standard library, so you're tied into that one, much like the story with async currently, right? And then on the topic of the language being difficult to use, we have some folks who have experimented with like scripting languages, embeddable scripting languages that interrupt very nicely with Rust. And you can perhaps use that as a migration path for new developers, especially front-end developers, to come in and get acquainted with something that's Rust-like, but isn't quite as hairy and prickly as Rust often is. So do you think either of those two things would help welcome more developers in and get around the hard, steep learning curve of Rust?
So one of the problems that I'm guessing, at least the garbage collected language or the scripting language, they're either implemented as a macro or they create essentially a new language with completely new parameters, and this is a percentage, right? Like we have so many people that are doing Rust, and then a small percentage will bother to learn that new language or something like that. And all of the educational resources are also going to be spread much thinner. So personally, as a web developer, I'm used to an immutable environment, right? I have to live with whatever works and doesn't work. So I have a similar approach to Rust, even if here I could probably try to change things if I tried. But so what I've tried to do is, for our UI structure, for instance, is to wrap all my references to the UI tree in a wrapper type that is an RC option or ref cell, or RC ref cell option to a dint trait, which is like, massive, ugly type, but it's hidden behind the interface. But that does mean that when you're dealing with UI objects in Rust, you can just pretend that it's JavaScript. You don't have to care. You can query it. You don't have to bother about the borrow checker, or all the borrowing is runtime. But because the granularity of the UI is so that you will never really hit the boundary of the API is sort of guarded, so you'll never hit the double borrow problem, because otherwise you move the problem to the runtime, which we're trying to avoid with Rust, right? So so I do think that within the constraints of Rust, for instance, one of the things that that makes Rust tedious is unwraps everywhere, right? Like option types that you need to handle. And for the beginner Rust developer, it's like, what is this? Oh, unwrap. Okay, sref unwrap. I can't unwrap this. Okay, whatever. The thing is that for the reason that you put those unwraps is that you know that it fails there when it's null, right, or when it's none. But for our UI, because the UI is live codable, actually, whilst you're live coding the UI, buttons might completely disappear that are referenced in Rust, right? So the way I fix that is to make all the APIs that we have, like action button.clicked or something like that, they just fail silently. I can make them fail with a warning in the IDE, but they fail silently. They don't panic your code. So I do think that within the language that we have today, you can do a lot to approach scripting ergonomics without having to invent a new language or going to make a macro for everything.
Anybody else? So in the earlier talk, Alice was talking about Taffy, how they found the crate and sort of have to revive it. This question more for Martin. For Servo, it was also a very old project that was sort of paused for a while, and then you guys started resurrecting it again. So did you see or face any issues in terms of the code base being very old, or any language syntax issues with reviving or starting up a previously existing project?
Yeah, legacy project issues with the code. Yeah, I mean, one really fascinating thing about Servo is that it's one of the older Rust projects around. So there's a lot of code that dates back from old versions of Rust, and we're constantly removing it and updating it to reflect the new Rust features. Yeah.
So you did have to do a lot of the rewriting of the functionality. Would you have a guess of how much percentage you had to rewrite or tear out from the existing code?
It's usually minor things that just features that now exist in Rust that allow us to do away with code that we don't need anymore, or things that we move from a pre-build step or post-build step directly into the Rust code because of new Rust or cargo features.
Okay, so it didn't sound too bad.
I can also actually answer that one too.
Sure.
I've had a project since 2017, and I was using a lot of features that came out just after 1.0, and almost exclusively on nightly. So there's been quite a lot of breakage when you update from a pinned nightly version to a newer version. I will say that has gotten increasingly better over the years. So let's say over the last 2 to 3 years, when I update to a newer nightly version, the churn is significantly less. Some features have been removed that I liked, but I mean, that's just, I think, nature of finding things that weren't as good as they thought they were or were unsound or something. But I think some of the most major changes that affected me were things like the allocator API changing, right? So as an operating system, you have to implement your own allocator or any kind of embedded no standard environment. Other things I can think of are the massive push for const eval, right? So that was something that I looked forward to for a very long time, and I think we're almost getting to the point where it can do everything that I want. And then I think the third largest one would probably be GATs. Now that we have, that's generic associated types. Now that we have that, there's a lot of more flexible trait implementations you can expose to other subsystems, specifically in a large OS that has a bunch of different abstractions that we would like to be able to be implemented by many different, drivers, for example, or file system implementations. GATs are quite useful in that regard. So when those features came along, we did massive restructurings to adopt them, and it was a pretty significant undertaking, especially for the constant eval. But yeah, I think another one I'm looking forward to is async, and I haven't really used that too much because it's still changing, but hopefully once the Rust language receives some kind of general async type abstractions and function abstractions so that we're not tied to one particular framework like Tokyo or Small or Embassy, it'll be more, I think, feasible for us to dig into that. So.
Okay, great.
Actually, something I didn't mention was, in addition to the language and the syntax, we really feel in a project as old as Servo, the evolution of the Rust ecosystem. I mean, recently we were able to remove our dependency on OpenSSL because RustLS had matured so much that it just made perfect sense to use a native Rust solution rather than resorting to a C++ library that just complicates cross-platform development.
Right.
So we feel that quite a bit.
Okay, great.
So, as a former web developer, I try not to use features in nightly, as in deep break. So if there's a way to work around it, for instance, you have the question mark operator that is now a trait, but you can't really use that one yet because it's in nightly. Then you just make a result and put an extension trait on it and put some methods on it, and it'll do the same thing. It's ugly, but it works. And then it compiles on stable. So I always try to make, at some point I was trying to use a bunch of features from nightly, and then someone said, it doesn't compile on stable. And I was like, okay, whatever. I'll just remove all the features that I used. And it turned out that actually none of them were really that important. The only feature that I really need is line information in the proc macros. This has been unstable for years. I don't know why. It's this very basic feature. Because otherwise I cannot easily reconstruct a file line error in my DSL macro, because I cannot reconstruct the original file and line information. Because if I have it, what I do, because the comments, if you have a proc macro, your comments fall out of the input stream, right? They're removed by the tokenizer. So what you're left with is just the code. But because all of the white space and all of the comments are gone, I don't know where they were in the original file. So when I throw that into a secondary parser, I have to reconstruct the white space by using the line number information. It's just insert fake white space in there. So, but I can only do that if I have the file and line stuff. And otherwise, I have to sort of read the original source file or something, which is not cool. This is not cool. So that's the only feature I use of nightly. And I really hope it hits stable, because then I can completely do away with nightly. But as you said, it's true. It hasn't been breaking nearly as much as it used to be. Because if you used to depend on nightly, it was like throwing the dice whether your project would compile after an update.
Great, yeah, that's probably with the help of a lot of the Rust folks in the next room, I guess, language folks, so that's great. One other question I had was for Jorge, because you work at a consulting firm, right? So, and you have a lot of Rust expertise in terms of, language-wise, whereas most of the consulting firms I've seen are, like JavaScript or web dev, that type of company. So, do you see any advantages of using Rust so far, as a basis of knowledge for your consulting firm? And do you see any, customers outside that sort of like inquire about things related or projects related to Rust for you guys to work on or anything like that?
Great. It's true that we are kind of seeing a tendency, right? It's over the years, and it's happening that it's less uncommon to see web projects that are adopting Rust at some extent. For example, this year we have one client that they actually dropped they are in the process of rewriting all his solution written on Ruby on Rails, which is actually a very old code base, like more than 10 years. And for many reasons. Probably performance is one of the toppest one. The top one, they are, but they have another limitation as well. And they are actually in a new project to offer writing from scratch using Rust. And this is an amazing example that the thing that I would expect to happen with the time. I think there is also another more common situation over the time is like you have, for example, a big system with a composition of different microservices or something like that. Your architecture is quite complex. So it's the case that they are implemented in the technology that better fits for the purpose of the service. And yeah, that's an opportunity for pick Rust for specific cases. The critical paths in terms of performance should be is usually the common case. But yeah, it's a trend that is happening, and I think their language is doing a good show. Although there is a concern in the community of the Rust community that they have to grow the user base, but I think it's already happening, and doing, let's say, web programming or web systems using Rust is less exotic than in the past.
Okay, so I think hopefully, with this conference and the works of Rick and other developers, we can push that much further and get it to a wider audience.
Yeah, in that sense, Rust is already very strong on the back end because it's a direct safety, performance, and scalability result. Just less servers needed. So servers cost money. Therefore, having a highly performant servers in Rust that is also reliable and robust is a clear-cut economic choice to make. So for that, Rust already works. We're a bit more experimental in that we're saying, well, no, actually, Rust is also fit for UI because it creates high performance and very robust front ends just as well as it can do with backends. But yeah, that is a completely new space that we're creating here, and a couple of talks were about that subject as well. So we're trying to pull Rust from not just like a servo engine, which is an engine for developers doing JavaScript and HTML, but to turn Rust into a usable application framework comparable to what Swift does and or Flutter. But I think the strengths of Rust as a language for quality of code and performance of code is something that that has struck me the most personally as a developer, because I've been trying to build IDEs for quite a while, and this is the first time we're actually succeeding scaling the systems to this level with a very small team. In JavaScript, it always felt kind of flaky. In TypeScript, you had big performance issues, but now with Rust, for the first time, very small teams can reach very large and relatively complex applications. And I think that once, hopefully, what we also produce as proof will trigger a new wave of adoption for us in different domains, such as UI.
Okay, sounds great. I think we're running close to out of time, so I have the last quick question. What is your favorite or secret Rust crate that not many other people know about that you love and use, and what's the reason?
Well, I don't very much use other people's crates, but there's one I use that has amazed me, and that is an Objective-C sys library by a person named Sheldon, and he or she made a crate that you can write a proc macro to call Objective-C. So you can write Objective-C in Rust directly, and this is how we do all our platform stuff on Mac. I literally can write Objective-C. I can read the Apple docs and write Objective-C in Rust. And that to me was a mind is blown moment that Rust can bridge the language gap completely. And Microsoft did it with COM for Windows. But this is just a really tiny little macro that bridges that FFI to Objective-C. And yeah, Yeah, it's probably one of the, 3 libraries we use, so.
Yeah, it must be good.
I have to admit, something similar came to my mind. Which I sadly forgot the crate, but it was a crate that did something very similar, but for C. So you could write inline C, but with a completely different intention. It was meant to give C developers like a way out, so they can still write C code, but say they write memory safe Rust code. And I liked it very much of showing what you can do in Rust. And I think the proc macro is like, the proc macro support is one of the biggest new features compared to other languages. And yeah, I think these 2 examples show that very well.
Okay. Anyone else? Yeah.
I would have to say something in the domain of error handling, right? So we all probably know about anyhow and this error, but Jane Lesby has a really great crate called Error, which is a pun on Jane Eyre. And it's a really nice way to give color and more context to errors, and I just found it so enjoyable to use that it sprang to the top of my mind. So there are a variety of other error crates that I think are great as well, like Failure. I don't really know that went anywhere, but I thought it always had a great API surface and some neat features that went above and beyond anyhow. But yeah, error handling, you know, it's nice and it's great to augment what Rust already offers.
Anyone else want to share? Or if you have too many? Or if it's well known, it's fine as well.
I really recommend that people try this small crate called RG.
RG.
No, oh, okay. No, it's a very fast grep. I don't know.
Okay.
Yes, rep grep. Yeah, yeah. It's a new one. Yeah. No, I'm sorry. I can't think of anything
All right.
offhand.
How about Jorge? Anything? No?
If I say the deref trade, you kill me? I think it has kind of bad reputation, right?
Okay.
No, just joking. I can't think of an example.
You're not supposed to use deref for inheritance, but we do that anyway. Yeah.
We have the counter example. Makepad is like the counter example of, I think probably one of the few cases where deref is actually
Right.
a good option. So yeah, it probably is. It's funny, but yeah, but please use it with careful or just accept the common advice that is not a good idea.
Okay.
I mean, I get why it's a bad idea, but it's about being able to know what a property or a method refers to, and deref makes that sort of opaque chain. Yeah, as long as you don't hit that problem, in our case, because you almost never access the object from the outside with the deref, it is only for the internal inheritance chain, so yeah, it should be okay.
Okay, great. Any questions, final questions from the audience? No? Okay, if not, then I'd like to thank all the speakers for coming and also answering all those questions for everyone. Your presentations were wonderful, very helpful for everyone involved. So thank you very much. Thank you. Thank you to the audience as well. Thank you.